In this problem, we need to solve the following inequality and graph the solution set on the number line. We need to express the solution in interval notation. Here is our inequality. It's x plus 6 times the quantity x minus 5 all squared is less than 0. This is a polynomial inequality, and I'm going to use the boundary point method for solving this problem. Boundary points are points at which the inequality can change from true to false. It doesn't necessarily change, but it can change. So we need to find our boundary points. And we do that by changing our inequality to an equals. So I'm going to have x plus 6 times x minus 5 all squared equals 0. Now all we have to do is solve this equation, and luckily it was already given in factored form. So if you have a bunch of factors multiplied together equals 0, using the zero factor property, you set them each equal to 0. So I have x plus 6 equals 0. Subtract 6 from both sides, I get x equals negative 6. Next one, x minus 5 all squared equals 0. That means that x minus 5 has to equal 0. Add 5 to both sides, you get x equals 5. So in this problem, I have two boundary points, and now what I have to do is graph them on the number line. So I have negative 6 and positive 5. And those two boundary points divide the number line into 3 regions. So let me just put dotted lines to represent my regions. I have the region that is less than negative 6. I have the region between negative 6 and 5, and then the region between 5 and positive infinity. As these two boundary points are the only places where this inequality can change from true to false or false to true, all I have to do is test one point in each region. It really doesn't matter which test point I pick in each region, as long as I know it is in the correct region. So if I need a number less than negative 6, I'm just going to pick x equals negative 7. Now we just plug x equals negative 7 into my inequality to see if it's true or false. So I get negative 7 plus 6 times negative 7 minus 5 all squared. We need to see if it's less than 0. Negative 7 plus 6 is negative 1 times negative 7 minus 5 is negative 12 all squared. So I have negative 1 times negative 12 all squared is 144. And negative 1 times 144 is negative 144. Is that less than 0? That is definitely a true statement. So this whole region is going to be part of my solution set. I know I want that region. Now we need a point between negative 6 and 5, and x equals 0 looks like a great choice. It's the lazy arithmetic. But one thing I forgot to mention, you can never use the boundary points as test points. It has to be numbers in between your boundary points. So plugging 0 into my inequality, I get 0 plus 6 times 0 minus 5 all squared. Is it less than 0? So I get 0 plus 6 is 6. 0 minus 5 is negative 5. So I get 6 times negative 5 all squared. Is it less than 0? So 6 times negative 5 all squared is positive 25. 6 times 25 is 150. Is 150 less than 0? That is definitely false. I do not want that region. And now I need to pick a test point that's bigger than 5. So how about x equals 6? Plug that into my inequality. So I get 6 plus 6 times 6 minus 5 all squared. Is it less than 0? 6 plus 6 is 12. Times 6 minus 5 is 1. So I'm going to have 1 squared. So 12 times 1 squared is 12 times 1. 12 times 1 is 12. Is that less than 0? That is also false. So I do not want that region. Notice I had to pick a point in each region. Some students think this always goes true, false, true, or false, true, false. The pattern can be anything, so you must test a point in each region. So the only region I need in my solution is this one region here. And since my inequality is less than, I'm going to put a parentheses on it, not a square bracket, which I'd use if it was less than or equal to. So here is a graph of my solution set. And now all I need to do is write that in interval notation. I'm running out of room, so I'm going to write it directly above here. Where does my interval start? It's pointing all the way down to negative infinity. And remember, we always use parentheses on infinity and negative infinity. Where does my interval go to? It goes to this boundary point of -6 with a parentheses on it. So there is my answer in interval notation.